Hello and welcome to Volkov Labs Unscripted. This video are hands-on and full of technical details about our plugins for Grafana. Today we will talk about business intelligence. It's a new and exciting project we are working on. I will demonstrate how to try it on yourself and create your first alert rule. Let's go. First, let's open Volkov Labs BI Grafana GitHub repository. It's in Volkov Labs organizations. Click on the code button and copy the URL. You can also open it with GitHub desktop and download zip file and extract it. Next, in the terminal window, I'm using git clone command and paste the URL. The repository will be cloned in the Volkov Labs BI Grafana folder. Inside this folder, there is a provision dashboard, Prometheus configuration, application plugin, and a Docker Compose file. Docker Compose used to orchestrate Docker containers. It contains Grafana version 10.2.3, Postgres database with timescale extension, engine version 1.6.0, Prometheus to collect engine metrics, and a webhook JSON. It's a Node.js application to demonstrate how to work with the webhooks. Docker Compose pull to pull all the containers. If you don't have it yet, it will take a little bit to download all of them from repository, and Docker Compose up to bring up the containers. All the containers starting up, Grafana, database, and an engine. When engine started, the API server will listen on port 3001, and the Grafana is listening on port 3000. Let's go to terminal and open localhost 3000. Grafana is running in anonymous mode, so you can access it as a viewer. To be admin or editor, we have to sign in. Use admin as the default credentials to sign into Grafana. As I mentioned before, two dashboard provisioned, business intelligence demo and engine monitoring. Let's take a look at business intelligence demo. This dashboard contains three different panels: metrics panel, logs panel, and BI alerting panel. The metrics panel, it's a native time series panel, which use time series test data source with the static values. It also has three thresholds configured: base, 70, and 80. One of the values is 90, it's in the red threshold zone. Logs panel. This panel is a native logs panel, and it uses test data source with 20 randomly generated lines with different levels: critical, error, warning, and alert, which we'll use for pattern recognition and alerting based on the logs. And the third panel is the alerting panel. This panel is use business intelligence engine, and the request type is none to work with the API. First of all, we have to create alert action to create any alert rules. Let's go to actions and click on add action. Actions can be two types: HTTP request to execute endpoint with a method post, or it can be logs to write down the information about alerts in the backend in the logs, which then can be parsed using Loki. I will choose logs, and I will call it logs as well, and it's going to be used by default: test connectivity and save. Now we have our first logs action. Next, create alert rule. Click on alert rule. I will call it high values in metrics. To schedule this rule, I'm using cron expressions. By default, it's set to every 5 minutes. It can be hourly, it can be every second, it can be 5 p.m. on Sunday. We will use every 5 seconds for demonstrations to generate and perform some metrics, which we'll look later on. For the target, select Business Intelligence Demo, and the panel, select Metrics Time Series panel. Time range. Time range can be selected as the one specified in the dashboard, or it can be custom using the time picker. First, I'm selecting from dashboard. Next, we select evaluation. It can be two different types: threshold and regex pattern. Select thresholds, and in allowed range, select base. It can be also the middle range. If you have a high, low, low, and you select the range is in the middle, you can select only values which is valid values from 70 to 80. Select for this demo, select base. For the action, default action logs will be used by default, and you can also add annotation to display them on a panel. For this, I'm selecting display, disabled. Annotations can be added for the panel and dashboard, which we'll use next in next demo. Disabled and save. As you can see, the rule is scheduled right now, it's active. And using this card, you can see the details, how it was configured, stop, pause, and resume. Then any rule can be edited. And when it's edited, it will be going back to schedule state and then OK or alerting, and the rule can be deleted. Let's refresh, and alert rule move to alerting state. If you will go to terminal, you can see there is an alert was executed, and in the log files, you can see the JSON payload of a webhook. As we said, it have to be sent in the log files. Also, it was executed every 5 seconds per schedule. And next time when it was executed, because it was already in alerting state, webhook was not called. Go back to the browser. In alerting state, if you click on details, you can see the event details. What happened? It executed this data source, which it takes it from a dashboard. Then it was evaluated using the threshold specified in the panel. And it found one of the rows with value 90 with this particular timestamp, which triggered the alert condition. Next, let's create another rule. I will call it critical level logs in logs. The same, we'll schedule it every 5 seconds. For the dashboard, business intelligence demo, and for the panel, it's a logs panel. As you can see, I don't specify any data sources, any configuration or threshold. It's all taken automatically from a dashboard and a panel configuration. For the time range, select custom time range last 10 minutes. It will be randomly generated lines. For evaluation, select regex pattern. For the fields, it can be any field or it can be any specific field where you are looking for, like a title of the message. For the pattern, I'm looking for level equal to critical. For the action, same logs dashboard. And for that, for this alert rule, add annotation as a dashboard. The logs panel, it cannot display your annotations. I want to see annotation on my metrics panel to correlate my metrics with the logs when it happened. For that, select action dashboard, and in this case, annotations will be created in Grafana and will be displayed for all the panels on this specific dashboard. Because the logs panel, it cannot display your annotations. Time series can. And click save. Now we have 2 different rules, critical level in logs and high values in metrics. When you create your new rule, it's moved to the schedule state and it's active. Let's refresh, and now it's moved to alerting state. Same with going to details, you can see what happened. It's executed with query, and then it found this row with a critical level. Because it's a randomly generated lines, sometimes it can be alerting state, sometimes it can be OK state, when it's there is no log levels with the specific critical levels. Let's look at the log files. And with log files, you can see there is an error. Alert critical level in logs, unable to create annotation, access denied. This is expected behavior because we are running Grafana in anonymous mode and as a viewer. It doesn't have editor permissions. For that, let's go to administration, service account, a create and service account, which will be used by the engine. Go to, we assign editor role for the big, create, and add a service account token. This token is going to be used by engine to access Grafana with a specific permission you specified. Copy it to the clipboard and close. Next, stop the containers. And we need to provide new token in environment files. For that, we will use VI tool. You can modify it in any tool of your choice. This environment file contains different configuration. Now we are interested in Grafana token, which is set to the service account token placeholder. Set the token, save the configuration, and bring up containers again. Engine will be restarted. By default, engine started in a debug level, and as you can see, 2 alerts was already started, added as the cron jobs. Some of them already started executing, and it's already added the annotations using the specific service account permissions. Let's go back to the dashboard. It's OK state, and now you can see the annotations created on this specific panel. This annotation indicates that in this particular moment of time, alerting engine found log lines with a critical level log, and it's marked every interval of time, if it's going to be interval or it's going to be one at a time annotation that this event happens. Because it's a randomly lines, it's going to be populated in different places. Next, let's take a look at another dashboard called engine monitoring. With engine monitoring dashboard, it takes information about Prometheus data source. It has a dashboard variables, engine 3001, 3002 as the instances. 3001 it's API server, 3002 it's a scheduler, which used to schedule and execute alert rules. It has a different alerts as well, the one we already created. In alert result panel, you can see there is a critical level in logs with the different states. There is alerting, error state when annotation cannot be created, and there is the OK state, and high values in metrics with alert was always in alerting state. You can see the alert latency with critical level in logs. It spent 25 milliseconds for evaluation and 29 seconds to create annotations. And because it created multiple annotations, the same time, create annotation took 30 milliseconds, and high values in metrics. Next section, it's requests. You can see how many requests was processed by engine API and how many requests was sent to the Grafana API. And you can see latency per each request. Next section is the processes. It contains information about Node.js metrics for two different instances, engine 3002, engine 3001, event loop lag, memory usage for each process, and active handler and request total. With CPU usage panel, it's a very interesting one. It's a native time series panel. It has two different queries, query A and query B, with irate, which use instance dashboard variable, and it has two different thresholds configured, base and a 2. Everything what is more than 2% usage, it will be marked as a high usage. And as you can see, with our alert rules, it uses more than 2% in a couple of times. Let's create a new alert rule for this CPU usage. Go to business intelligence demo dashboard, and as you can see, there are so many annotations was created recently based on a random generated log lines, which was at the critical level. Let's create a new alert rule. I will call it high CPU usage. I will execute it every 5 seconds to get some load done. For the dashboard, you select engine monitoring, and the panel type CPU for CPU usage. This configuration was automatically loaded from a dashboard. The time range is last 1 hour, and it automatically recognized that different queries for this panel use dashboard variable called instance. It can have all value, or you can specify specific value for this variable. You can also select a repeat by, which means that if you select all, it will be only one query executed at the same time for both instances. If you want to have a separate queries executed separately for the API server and the scheduler, we select repeat by. It is the same concept as you can use for panel repeat by in Grafana. Then for evaluation, select the threshold, and allow it range, I can select base. There is also override section, which is available for the variables. In this section, I can specify that for engine 3002, it can have different allowed range. It can be bigger range, wider range, or it can be totally different range than my API server. So using these overrides, you can, in one rule, you can say for different instances, devices, you can specify different evaluations, and all of them will trigger alert based on the different requirements. I'm not going to use overrides for this demo. And for the add annotations, this demo, for this rule, we will use panel and the default logs action. Click Save. These rules are grouped by the dashboard. There is a business intelligence demo with the 2 alerting, and 1 is scheduled. Let's take a look at the logs. As you can see, this alert was executed, It's requested webhook body, printed with webhook body in the logs as we wanted it to, and it created multiple annotations for every moment of time when the CPU usage was more than 2%, and it's already started to schedule more and more alerts. Let's go to engine monitoring dashboard. There is a new high CPU usage alert, which in five times triggered in alerting state. There is also latency for it. As you can see, Grafana API request increased based on this new CPU rule, and this rule used with special post-DS query request to trigger to get the result for two different engines separate. In this CPU usage, let's take a look. It created annotations for every interval of time with a specific instance when the threshold was breached. This one was breached by engine 3002 scheduler. This one was API server. If the load is continue and the alert was triggered every 5 seconds, with annotation, it's automatically extended. So in this case, you can see there is a bigger range for this specific rule. Let's go back to last 1 hour. Now we'll go back to the business intelligence demo and add a new panel. For this panel, I will use native table panel, data source business intelligence engine, and for the request, alert history. This specific request will show us all the alert history which happened for all the alerts. In this history, you can see there is alert ID, alert title, duration, event, JSON payload which can be used for transformation to display a different configuration, previous state, new state, when this state happened, and end date. And empty end date means that this alerting state is still ongoing. And this was the alert history. And that was a brief demo of how we try the business intelligence alerting and created a new rules for the critical level in log files based on regex patterns, how we look for high values in metrics, and then at the high CPU usage, where we use variables with dashboard variables instances with the different allowed ranges. I hope you enjoy this demo. I hope that everything was clear. Let us know if you have any questions in the comments down below. And we are looking forward for your feedback. And if you like this content, subscribe and share. Thank you for your time and see you next time. Bye.